The following research and technology is brought to you by the DST Foundation. We would like to thank Gerald Pollack for his profound work with water and for inspiring this annual conference. Evgeny Germanov and the General Conference sponsor DST Foundation. We also extend our sincere gratitude to the conference speakers and attendees, as their research, support, and interest help to make this conference a great success. I will begin with a generalized brief introduction to the IC project and will then hand it to Sergei Kernbach, the DST Fund IC project partner and scientific researcher specializing in measurements and detection of super-weak electromagnetic emissions. Here, Sergei will explore transmission of specific field generated by a primary substance over long distances and changing the state of a secondary substance under the influence of specific field. So first, I want to show you a little video that poses a rather interesting question. Okay, the DST Fund Endeavor IC project is set at an intersection of such sciences as physics, chemistry, biology, and medicine. The IC project is dedicated to developing the technology of remote transfer of informational copies, otherwise known as super-weak electromagnetic emissions of biologically active substances via communication lines with additional IC transfer to a temporary carrier. Following informational copy transfer procedures, temporary carrier may be used as a source of biologically active super-weak electromagnetic emissions for specific effects on water and aqueous systems. This project combines the following natural phenomena. Biological objects emit super-weak electromagnetic emissions, also termed as informational copies, IC. With such emission, these signals have an effect on water in other living systems in a characterized manner. Informational copies may be emitted also by non-living systems, for example, chemical compounds. Informational copies of chemical compounds have a coherence effect on biosystems, and notably water. Under influence of informational copies, water changes in physical or structural properties and becomes an informational carrier for this emission signal. Informed water has been shown to have effects on biological objects similar to the effects of the substance in which the informational copy was derived. Water, as an informational carrier, retains informational copies and further becomes an informational copy source, carrying with it intrinsic features from the original information source, much like a photograph of a photograph. For nearly 100 years, scientists have been studying phenomena related to emission of biological objects and chemical substances, as well as influence of emissions with different characteristics on living systems, transmitting emissions on water and other temporary carriers, and distant transfer of emissions. Multiple studies published in peer-reviewed journals explain experimental proof of these phenomena existence. Theoretical studies reveal characteristics and mechanisms of the processes, showing that cells emit EMF, cells react on external EMF, cells interact with EMF. Scientific explorations and various methods of transferring informational copies at a distance by means of informative communicative networks and investigating effectiveness of their impact on biological systems. In 2000, French-known immunologist Jacques Benveniste, along with collaborators, reported on PMA leukocyte activator biological activity transfer to target cells using electron communication channels. PMA was put into a solenoid and connected to a radio amplifier input. A neutrophil suspension was also put into a solenoid and connected to the output of the same amplifier. Neutrophil activation was confirmed by results of 20 blind experiments. The hypothesis was as follows. PMA solution become a source of a certain signal, which may be transmitted via electron communication channels, which are shown to remotely influence neutrophils under the absence of direct chemical contact with cells. Luc Montagnier, recipient of the 2008 Nobel Prize in Physiology or Medicine for his discovery of HIV, used a Benveniste device and established highly diluted DNA solutions of certain pathogenic bacteria and viruses to be sources of electromagnetic irradiation of frequency within several hundred hertz to several kilohertz. As genomic DNA of most pathogenic bacteria contains such segments, it becomes possible to create a highly sensitive detection system for humans and animals with chronic infections. According to this method, a patent application was published in 2012. In 2012, Alberto Felletti and a team of Italian researchers published a paper in which the signal transmission was made from the solution of retinoic acid, a well-known agent of differentiation on the medium in which the tumor cells were then placed. As a result, it was found that the prepared medium had a negative effect on malignant cells. Scientists from multiple countries representing various branches of scientists are cooperating to experimentally prove these phenomena exist and have a crucial and practical importance. In service to conventional methods and approaches, the obtained experimental results serve as a basis for existing and developing systems, allowing researchers to implement super weak electromagnetic emissions of informational copies in medicine, agriculture, and veterinary science. Currently, our growing global network of physicians and researchers have performed more than 5,000 tests in clinical observations. Of the patients treated by informed water remedies, results of conventional studies have shown high efficiency and little or no side effects in comparison with their associated chemical analogs. So now I'm pleased to introduce to you Serge Karnbach, DST Fund IC project partner and scientific researcher specializing in measurements and detection of super weak electromagnetic emissions.
I would like to speak about precise measurements behind IC medical's technology, and a little bit more general on socialization of unconventional technology and this, all this problem when we encounter when we make application of this technology, or for instance, speaking with our friend about it. We are friends and partners of DST project, but anyway, independent laboratory perform this measurement for our customers, different customers. Well, I would like to start with this. Stuttgart is a car city. We are heavily impacted by car, Porsche, Daimler, Porsche. I would like to take these pictures from the socialization of this technology in the car industry. Originally, it was discovery of engine. There was 80 years before that get really kind of useful engine. Then there was a slow process of understanding, making models that created a secondary process of product. Improvement of products that's created a market. And this process of marketing and knowledge lead to further discoveries in this car. And interestingly, there is a whole process that create a new branch of science and technology, and exactly the whole stuff create a kind of social acceptance of this technology for society. But anyway, the key point still this discovery, because without discovery there is no acceptance, no technology, no market. And the main points here are: is this fiction, is this useful, and it is well reproducible. Now, when we try to transfer this idea to unconventional technologies, I pick up a few points from IC medical technology with an example of, let's say, penicillin. The point of discovery, well, the penicillin has a kind of chemical structure, I will know. It's an impact of chemistry and then biological organism. But the first point of discovery is a kind of super weak emission behind chemistry. Well, there is a kind of impact of this emission and biological and non-biological organisms and many different substances. And there is a long-range transfer of weak emission. The question is this a fiction? Is this, we assume this is useful, but the question is this a fiction? Can we really reproduce it in many times in independent experiments in independent laboratories? All this research that appeared or was performed in the Soviet Union in the 70s, 80s, and 90s with massive governmental funding. But still, 30 years after this, we have this question. Why this discovery, I mean the whole discovery, and in particular in the IC medicals field, did not emerge as socialization and wide acceptance of this technology in society? I mean, there are many questions from the kind of positivistic philosophy of science, kind of damaging prehistory they have to find with these things. But I mean, I would like to focus here on this discovery stuff and to say that all these 3 points in the technology is not fiction and is well reproducible. And I start first with a measurement of this weak and super weak emission. I mean, when you cannot measure it, maybe it doesn't exist at all. So measurement is a key point of the whole story. And how to measure this. We work for a long time in this field, and with several sensors that we develop over these times. In this case, we use a kind of potentiometry as a pH metry, quite standard approach. We use the standard electrodes, but there are 2 differences. First of all, we use a quite high resolution. It's about 10 of power minus 5 minus 6 as the highest resolution. And secondly, you have to thermostabilize your probe to prevent impact of electromagnetic field, mechanical impact of everything. You have to protect almost from everything here, and this towers, protection towers. And then there's a kind example of measurement what we do. We start measurement for several hours for background measurement. And in the background measurement we receive a kind of signal, a little bit noise, some small changes of signal. It's generally the weak emission is impacted by many factors. And then it was quite inspired from IC medicals. We take this CD and then put CD under the measurement device and perform measurement also for several hours. And in this measurement, again, we have to remove all people from laboratory. You know, it is very sensitive to almost all these different impacts. But after this, you see there is a change of pH. So there's very, very small changes. Like I said, it's a difference as a range between 10 of power minus 3 up to 10 of power minus 5. But nevertheless, it's well visible changes. Just take a look at this back side of this thermostabilization tower. It's a metal sheet. There's 2 metal sheets. There's a vacuum inside. I mean, it's quite protected from all possible kinds of electromagnetic emission, from thermal impact and so on. I mean, there is no electromagnetic weighties of impacting this object and water samples. We perform measurements, that was kind of examples of this device. It's a biological object. We just take a green leaf and put it up on this device. And you see each time when we insert it and remove it, we observe a change of trend, of pH trend. There was a number of papers what we published in this technology. This last paper, this appear right now in iTunes. For this, we took 88 measurements. All this measurement was very similar. There's a kind of background measurement, it's almost a line, and then you observe a kind of impact. Well, in results, we received a positive result about 92% of repetition. When we just only account inserting CD in the devices, it was about 93%. And with the green leaf, about 75%. I mean, it's a kind of quite a good repetition with a great statistic on this. Well, the next idea was fine. We can measure more or less a kind of weak impact, which we cannot count to electromagnetic or thermal or mechanical emission. But what's about this activation of water? I mean, exerting to different electromagnetic field. And we consider two different approaches, or two different cases. As in this case, we use a differential approach. We use always two samples. And in the first case, we exposed both samples to equal electromagnetic field, or for instance, to not expose it at all. So we have a kind of equally actuated samples. And in the second case, at least in all of these times, we used very, very different approaches for actuation. For instance, actuation is a kind of geometrical shape, as a well-known effect. With laser, with different electromagnetic system, this is a kind of LED. Here inside of conus, you can put different substances, and so actuated in this way. Interesting is the result. When we observe this with a DPH device, when we consider equally actuated samples, in both cases, I mean, you observe almost equal curves and almost equal behavior after the impact. But when you consider unequally actuated samples, you immediately see different behaviors in channels. And in this case, for instance, with very specific actuation, we observe a kind of 10-time difference. In this way, we can measure not only impact, but we can measure a kind of numbers behind this impact. We can say whether this actuation is more intensive or less intensive, or more useful or less useful. We try here to find a kind of good combination of different fields with the highest impact. Statistic on this we performed for IC Medical last year. This measurement was presented in this conference. It was about 40 measurements. Beginning of this year, it was repeated with 70 measurements, and currently we do this with cosmetic products, about 30 measurements, but we are just in progress. It will be much more. And the common picture is more or less like we said last year. When there is no impact or equal impact, we observe quite low difference. But when there is any impact, you observe a dramatic difference in the difference between activated and not activated channel. So in this case, we clearly see that we are able to measure kind of weak emission from different objects. It's well repeatable, and we can accumulate a large statistic of this phenomenon. What is about the second point, long-range transfer of weak emission? I should say that the whole story regarding this long-range transmission is from communication, as a non-electromagnetic communication, and this was explored in Soviet Union for the submarine communication, military field, so it's quite in those times it was quite well researched. Unfortunately, it's not really good published, but we try to, many people try to recover this technology. So it's a typical communication where you have sensor on one side and the emitter on the other side, and when you switch on emitter, you receive some signal by sensors. In this case, we use many different sensors. In this case, there's a conductometric approach. You measure current through water, but it's a very specific way. First of all, it's a DC conductometry, and you need deeply polarized electrode electric layers. And you have again to stabilize samples, again temperature, electromagnetic fields, and all the possible things. Well, for emitters, we use again different emitters. This was LEDs, but this specific kind of LEDs with high voltages. Laser emitter, electromagnetic emitter, combination of electromagnetic fields. There's an electromagnetic emitter with specific geometry, the generating pointing vector. Well, what this was set up? There was one of the years set up in 2013. We have a kind of metal box. In the laboratory, we put a generator here, then remove generator over the walls, water. It's a small video. Here are the sensors. And you see there's a thick concrete walls. It's in our basement in the university. And thick metal doors. All this idea about electromagnetic impact or kind of electromagnetic connection between receiver and emitter, it's no way. There was one of the first LED emitters. So from batteries. Yeah. Okay. What was the behavior? We do like, in normal way, record background measurements, and then this gray line is the impact. The generator was switched on, and you see in all cases almost the same thing. So it's a kind of line and background measurement, and change in the trend and the impact time. There's many different repetition of the same. For instance, 2 times switch on, switch off. I mean, it's almost the same things. Well, we published it in GSE. It was 233 repetition of the same experiments. I mean, it's very simple to repeat it many times, or we done it. The success rate about 81%. It's quite high for more than 200 experiments. After this, there was extension of this experiment. We started to use long-range signal transmissions between Stuttgart and Chisinau, Stuttgart, Moscow, Stuttgart, Tomsk, Stuttgart, Perth, Stuttgart, New York, Perth, New York. I mean, one of the longest what we had, about 30,000 kilometers. With the same setup, more or less. We generated, we had sensors. In this experiment, there was 670 repetition of more or less the same thing, published in, I think, 4 or 5 different papers. And I would like to point on this, 30,000 kilometers, and power of emitter is 1 milliwatt. I mean, 1 milliwatt for 30,000 kilometers. And there was a night time, we were sleeping. And when we come in the morning and take a look at the data, we see immediately after the beginning of impact, jump in the sensor values. 1 milliwatt. Well, this absolutely nice experiment. This was proposed by Professor Maslobrod from Chisinau, his Academy of Science. There's overcooled water. It's minus 25 degrees for almost 1 day. And there's a generator, and there's a link. There's 4 samples, and there's a link to sample number 2. And the idea was that this overcooled water is extremely sensitive to impacts. And the distance is 10 meters. It's again no way of electromagnetic impact. Please take a look. Oops. Just frost immediately after something like 10 minutes of impact, and it froze the sample. In the video, there is recording more than I think 2 hours, and no other samples froze. I mean, this really demonstrates how this impact of this weak emission over distances. Then the second point, at least in the technology, what we measured, and not only in this specific case, but in more in different cases, what we had. This is well repeatable, and when we consider all this, I mean, the military things, what they've done, it's statistic is huge, and it's normal, it's huge. Well, now as the last point, impact of a weak emission on biological organisms, whether it's really so. It's a simple thing, what I think everybody can repeat. It's a pipe, and you can pump water through this pipe. There's a kind of coil. And we put 2 plants on the side of the coils, and they die after 2 or 3 weeks, it depends. You can, repeat it at home. It's not really advisable to do it at home. It's quite a pathogenic emission, but it's the simplest example how this non-electromagnetic weak emission can impact biological organisms. In this term, this is negative impact. We use a standard approach, at least for measuring these things, with microbiological measurements, first yeast. And the idea is that the activity of yeast or metabolism is impacted by this stimulating or inhibiting emissions. And they produce CO2, and we measure pressure. And it's very simple to do this. And at the end of the day, you receive something like a car with lowest pressure and with highest pressure, and you can very easily differentiate whether this impact was stimulating or inhibiting, and you can count, okay, what is the intensity of this inhibiting or stimulating emission. I would like to go a little bit more in detail in other kind of experiments we performed with Chisinau. This was Institute of Plant Physiology and Genetics. We worked almost 1 year in these experiments. There was 60 different types of experiments. The distance between our cities is 1,500 kilometers. We performed over 50 attempts, and they specialized in plants. In this case, it was zits, as a different setups with zits. And because of large number of seats as a great statistical, all of them use 3 different setups. And I mean, in all of this setup, we observe a kind of increasing of experimental population when we do a stimulation impact, increasing over the control populations. The difference was between 20% and 50% in almost all cases. So it's also published last year in 2 papers. And I think in those experiments, we first time perform a distant impact of pathogenics and stimulators and real conditions. And I mean, we somehow repeat the more oldest results from 80s, where people tried to explore remote impact of different substances and biological organisms. They was again published. We do right now this with different farms in France and in Germany. I think it's a good example how this technology goes not from scientific side but from application side, and this creates a kind of social pressure for acceptance of this technology. This last example from this long-range impact, this was done by Professor Maslabrod the first time. He published 2004 first time, he then repeated a few times. The idea was then when there is a set of jointly sweet seeds, I mean that could be from one plant, but it should be kind of common factor behind all of them. And he divided this in 2 parts and set a gamma radiation as the third part. And the cytology laboratory performed measurement of chromosome dysfunction. Of course, this encounter many dysfunction. But strange was the distance between both was about 7 kilometers. And when they investigate the second part, they also discovered chromosome dysfunction. It's absolutely amazing fact that, I mean, there are many implications. One of the applications should be quite carry forward with what we are doing in a remote way, because we can quite easily distort DNA material from biological samples in this way. So, when I try to conclude now in regard to asymmetrical technology, I mean, back to this scheme, at least in all of these points, and in more larger, I mean, many different points of this unconventional technology, we can say it's not a fiction. It's useful, it's not a fiction, and we are able to measure this in statistically significant manner. Of course, the question is now how to proceed further. Should we publish it? Should we go more in application field? I mean, it's quite an unknown question for us. When I mean, try to formalize these things, I think that's what was said before here, that using standard physical measurement is quite successful, and we can do a lot of repeatable measurement and with high significance, but we should not forget that it's not like measuring a voltage. It's a dramatic difference because this weak emission is very sensitive to almost everything. To astronomic events, to natural rhythm, to psychical effect of operator. We have many measurements when the human entering in the building, not in the measurement room, but in the building, and we cannot measure anymore. So it's quite of very strong impact of all these additional factors. Of course, some ethical about this military misuse, and this should be somehow also taken into account. And explanation, I mean, the very important point, how to explain everything, because without explanation we cannot really work successfully in this field. At least what we trained is more than quantum effects and macroscopic systems. It seems more and more people I mean, publishing in this field. It's a paper from Repeatable in Nature, there's a paper in Science, and there's many papers appearing now in different journals on this field. At least I personally believe this may be kind of explanation of what we can use in further work. Okay, thank you very much.